In this lesson, we're going to take a look at the definition of an algebraic function, as well as doing a little bit of a review of linear functions. Let's start off with what is a function. A function is a relation in which each input value has exactly one output value. That means if I have two groups of numbers, my input numbers, or my x numbers, are going to match up to only one output number, or y number. Functions are generally written in function notation, which means a function of the input is going to be equal to the output. We take the x value, we put it into some sort of function rule, whether that be a graph, a table, or an actual equation. And when we simplify that and evaluate it, we're going to get an output value in return. The domain of a function is all possible x values or input values, whereas the range is all possible y values. Depending on the type of function, we may have some sort of restriction on the x or the y values, so that's going to affect its domain and range. Domain and range are generally written in interval notation, where we look at the smallest and the largest possible x and y values. An algebraic function specifically is a function that has an expression where there are a finite number of terms that only use algebraic operations. Now, what are our algebraic operations? That's addition, subtraction, multiplication, and division. In there, you'll also see radicals are really just a type of exponent. It's just written a little bit differently. You'll see algebraic fractions, rational functions, and then we'll have our polynomials where we have powers that are integers. And of course, we're going to have lines, which is what we're going to look at next. So you could see some examples of algebraic functions here. These in this other right side oval are not algebraic. So here we have logarithms, we have trigonometry, we have exponential functions. Those are not algebraic. Again, our algebraic functions just use algebraic operations. A linear function is a type of function where there is a constant average rate of change. That constant average rate of change is our slope, which measures the steepness and the direction of my graph. So that tells me whether I'm increasing or decreasing and how fast I'm increasing or decreasing. Linear functions are of the form y equals m, which is my slope, times x minus x1. x1 is just the x value of any point on the line, plus its corresponding y value to that point. So if I want to graph a linear function, I have all the information that I need. I need the slope, which is 1/3, and I need any point on the line, which if we go back to this general form, we could see it's going to be 2, 5. So the first thing I'm going to do is plot that point, 2, 5. Next, I'm going to use my slope to find 2 more points on the line. So my slope is telling me that the change in my y value is 1 and the change in my x value is 3. So I'm going to go up 1 and then to the right 3 places. I'm going to do that another time to get a third point because 3 points will give us the most accurate line if we're doing this by hand. So again, I'm going to start off at that second point, go up 1 and to the right 3. Now that I have 3 points, I could successfully draw an accurate line. So I'm going to connect and extend in both directions. Now that we have our graph, we can easily discuss the domain and the range. So we're still looking at f of x equals 1/3 x minus 2 plus 5. My domain here, looking at my graph, I see that there are no restriction on my x values. I don't see any breaks in my graph, no jumps, no holes. So every x value can be in this function, which means my domain is all real numbers. My range, I see the same thing. There are no breaks or holes in my graph. Every single y value is allowed, so my range is all real numbers. Written in interval notation, I have from negative infinity to infinity represents all real numbers. To review what we talked about how a function is a relation in which each input value has exactly one output value. An algebraic function is just a type of function that uses algebraic operations, which are addition, subtraction, multiplication, or division. Every function, whether it's algebraic or not, has a domain and a range. The domain is going to be all the possible input or x values. The range is going to be all possible output or y values. Our domain and range are generally written in interval notation. When I have a linear function, that means that we have a function that has a constant average rate of change. That's what forms a line. That's why there's no zigzags or jumps or breaks in my line. The slope is going to tell me how my function moves from point to point. So I could plot a single point when I'm in that point slope form and use the slope to plot 2 more points. Once I have those 3 points, I can easily connect and extend them to draw my line. We also saw how a linear function has a domain and a range that are both all real numbers. That's because a linear function has no restriction on the x or the y values. So both the domain and the range are from negative infinity to positive infinity.